So we're finishing up our unit on statistics today, and we're going to put our ideas of the empirical rule together with our ideas of the standard normal distribution, making use of some z-scores in the middle, so really pulling a lot of ideas together to be able to figure out percents of a population that does a particular thing. We're on page 33 in the notes, and before I explain to you how we're going to do these problems, I'd like you to take a look at the problem on the bottom of the page. A survey indicates that people use their computers an average of 2.4 years before upgrading to a new machine. The standard deviation is 0.5 years. I want to figure out what percent of computer owners use a computer for less than 2 years before upgrading. Well, here's how I'm going to figure out what to do with a problem like this. I'm going to kind of jump between the top of the page and the bottom of the page. First thing I'm going to do, I'm going to sketch a normal distribution, and I'm going to label the mean and my data value, or values if I'm trying to figure out between two things. Step number 1, I'm going to sketch a normal distribution. I am going to label the mean and our particular data value, or values if there's more than one. The first thing I'm going to do with any of these problems is I'm going to sketch a normal distribution, label the mean and the data values. As usual, if I'm going too fast for you, push pause anytime throughout this video to help you get caught up. Back to our example down here, I'm going to sketch a normal distribution. What's the mean amount of time that someone owns a computer before they upgrade? 2.4 years. I want to figure out the percent of people who own a computer for less than 2 years before upgrading. So I'm going to put a tick mark at 2. Well, the next thing I'm going to do is I'm going to shade the region that I care about. What do I care about here? I care about the percent of people owning a computer less than 2 years before they upgrade. So I'm going to shade that region over there. That's going to be my second step in my process. Step number 2. I'm going to shade the appropriate region. I want to figure out the percent of people who own a computer less than 2 years before they upgrade. I want to find the percent of people who own a computer less than 2 years. Well, what I now need to do is I need to convert my numbers in this problem into z-scores, because z-scores tell us how many standard deviations away from the mean we are. And the important thing is that standard normal table that we had can then be used to figure out a particular percent of data. I'm going to go back to our steps. I'm going to write this down before I actually do it. Step number 3, I'm going to convert the data values to z-scores. When we're done with that, we'll state an inequality. I'm going to convert the data value I have, so that 2 years, I'm going to convert that into a z-score. Then I'll give an inequality for this problem, and then I'll be just about there. So I need to turn 2 into a z-score. I know that my mean is 2.4. I know my standard deviation is 0.5. Hopefully you remember our formula for the z-score. Z equals our data value minus the mean divided by the standard deviation. So my z value for 2 is going to become 2 minus 2.4 over 0.5. You're going to want to go to the calculator probably at this point. And that should give you about negative 0.8. If we were dealing with our standard normal distribution here, the mean would be 0. This tick mark over here is at negative 0.8. I now want to find the percent of data whose z-value is less than negative 0.8. How do we do that? Well, that's exactly what the last video was all about. If it's a less than problem, we can pull that straight from our table. If it's a greater than problem, we'll do 1 minus what's in the table. And if it's a between problem, we'll do one table value minus another table value. Going back to our process, step number 5, I'm going to say use the standard normal table, what's on page 29 and 30 in your notes, to find the required area. Use the standard normal table to find the required area. And then, of course, be sure to write your answer as a percent. We're going to use the standard normal table to find the required area. We can do that because now we're dealing with z-scores rather than actual data values. And then we'll just write our answer as a percent. Well, I want to find the percent of data whose z-value is less than negative 0.8. You're going to go to your standard normal table. You're going to go to the negative side. We're going to find negative 0.80. That's 0.2119. Which means we can predict that about 21.19% of people own a computer for less than 2 years before they upgrade. Let me show you another example. Survey indicates for each trip to the supermarket, a survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. Obviously, this is like talking about normal times, not nowadays when everything's just sort of a mess at the grocery store. You can spend an hour just waiting in line to get into the grocery store. Anyhow, the length of time spent in the store is normally distributed and is represented by the variable x. Shopper enters the store. I want to figure out, in part A, the percent of shoppers we can expect to be in the store between 24 minutes and 54 minutes. Here goes my process. I'm going to first go and draw a normal distribution. I know the average, the mean, is 45, so I'm going to put a tick mark at 45. I want to know what percent of shoppers are in the store between 24 minutes and 54 minutes, so I'm going to put tick marks at 24. And another one at 54, and I'm going to shade. This is the region that I care about. I'm going to go, and I'm going to convert those x values into z-scores. 24 minutes, that has a z-value of, well, let's see, 24 minus my mean, which is 45, over the standard deviation, which is 12. Go to the calculator. I think that should be negative 1.75. Might as well fill a z-score in over here. No, you don't necessarily have to do this, but I think it may make it easier to see. I know that has a z-value of 0. And then we have to convert 54 minutes into a z-score. I go to 54 minus 45 divided by 12. Should be 0.75. Which means I really want to know what percent of people have a z-score between negative 0.175 and 0.75. I do need to see an inequality like this written out. This is the problem I now need to do. Go to your standard normal table. We'll figure out the area to the left of 0.75 minus the area to the left of negative 1.75. Let's see here. 0.75, that's looking like 0.7734, minus, okay, to the left of negative 1.75, that's looking like 0.0401. calculator. That's 0.77, no it's not. That's 0.7333. So I can predict about 73.33% of people would be in the grocery store between 24 minutes and 54 minutes. One more. What percent of people are in the store for more than 39 minutes? Well, I'm going to go draw my normal distribution out. I've got my mean of 45, and the data value I care about is 39, so I'll put 39 over here. More than 39 minutes, I care about this stuff. Let me go turn 39 minutes into a z-score. Z-score is going to be my data value, 39, minus the mean of 45 divided by 12. Negative 6 divided by 12, that's negative 0.5. So I want to figure out the percent of shoppers whose z-score is greater than negative 0.5. Well, I think you can probably do this calculation. You're going to figure out the percent of shoppers whose z-score is less than negative 0.5 from the table, then do 1 minus that. I think this should be 1 minus 0.3085, about 0.6915, or 69.15%. It seems like this is it for the notes, but I'm not convinced this was really enough for you to see what's going on here. So maybe we'll do one or so homework problems together just to get you a little bit more practice with this. Plus, then some of the homework's taken care of and you don't have to bother doing that. So let's see here. Let's go to problem 19 in the homework. Let's go to page 55, I think. Please read that problem. Wanted to figure out the height of males in the U.S. In the survey, there was a survey. They grouped people by age. In the 20 to 29 age group, the heights were normally distributed with a mean of 69.2 inches and a standard deviation of 2.9 inches. I want to find the percent of males whose height was less than 66 inches. Well, I'm going to draw my normal distribution. Yes, I will need to see these normal distributions and the tick marks and the z-score calculation and the inequality. There's a lot of stuff going on here. I'm going to put a mean of 69.2 inches. I want to figure out what percent of participants had a height less than 66 inches. So the people over here. We need to turn 66 inches into a z-score. Z is going to equal 66 minus, let's see, the mean was 69.2. Standard deviation was 2.9. So 66 minus 69.2 over 2.9. Go to your calculator. You're getting a messy decimal here. 1.10344 and so on. Well, because I'm going to go use my standard normal table and everything there is given to 2 decimal places, I need to round this. And I'm going to say this is negative 1.10. I want to find the percent of people whose z-score was less than negative 1.10. This one's going to come straight out of your table. So I think about 0.1357 or 13.57%. I would pause the video and see if you guys can do B and C. looking for that region. I don't even have to do the z-score calculation for 66. I already have that from the previous problem, negative 1.10. 72, though, I will need to do. 72 minus 69.2 divided by 2.9. Giving me a z-score of 0.9655. I'm going to call that 0.97. I want to know the percent of people whose z-score is between negative 1.10 and 0.97. Get these values from my table. I'm going to get 0.8340 minus 0.1357. That'll be 0.6983, or 69.83%. Letter C, how many people have a height more than 72 inches? Certainly not me. 69.2, 72 inches is over here. I want to figure out this percent of people. I already know the z-score, so I can really just say the percent of people whose z-score is greater than 0.97. I'm going to do 1 minus 0.8340. That'll give me 0.166, or about 16.6% of the people. That is it for statistics. You're going to try a couple more of these problems for homework. Number 19, though, I've already done for you, so really just scan in the notes you took, and that counts for your work on problem number 19, assuming you watched this video. That is it for statistics. We are done with this unit, and next class we're going to start our final unit about trigonometric expressions, equations, and functions, trigonometry. But more with that next time. See you later.